Hi friends, welcome back. Today we are going to solve Codeforces problem restaurant. Before we start looking into this problem details, some examples and the Java solution for this problem, I want to mention that my channel is dedicated to help people who are preparing for their Java J2 interviews and for their coding interviews. On my channel you will find a lot of helpful videos that can help you in your Java interview preparation and in your coding interview preparation as well. There are over 250 solved different varieties of coding problems you will find on my channel, and those are the coding problems taken from previously asked coding interview questions by Google, Facebook, Amazon, Apple, Microsoft, Yahoo, and many other big tech companies. And those are selective problems in the sense that they cover very important coding questions varieties such as BFS, DFS, matrix problems, graph problems, binary search tree problems, dynamic programming problems, problems related to linked list, strings, optimization, priority queues, and a lot of vast varieties of problems that are very important from coding interview perspective. So please subscribe to the channel. This channel can definitely help you in your job interview preparation. So please subscribe it. So let's look at the restaurant problem statement first. A restaurant received in orders for the rental. Each rental order reserved the restaurant for a continuous period of time. The ith order is characterized by two time values, start time and end time, right? Li and Ri. Restaurant management can accept and reject orders. What is the maximal number of orders the restaurant can accept? No two accepted orders can intersect. They cannot share even a moment of time. If one order ends in the moment other starts, they cannot be accepted both. Uh, so in the input, let's take what format the input is given to us. So the first line contains number of orders. So let's say in this example, right? So number of orders are 5 here, and the following n lines contain li and ri, which is start time and end time, right, for the order. So these are the description of orders, which is 5 orders and start time, end time, right? So for example, start time for the order 1, start time is 1, end time is 2. For order 2, start time is 2, end time is 3, like this, right? So we have to find out maximal number of orders that can be accepted by the restaurant, right? So let's take this example over here on the whiteboard. So this is the same example. I just created the basically these are the orders that are given to us. These are the 5 orders. So what I did is I just plotted on the timeline, right? So this is the start time. Let's just consider this one, right? So let's say this one is our order 1, right? So let's say this one is our order 1, right? It is from 1 to 2. Then order 2 is from 2 to 3, right? Then order 3 is from 3 to 4. Then order 4 is from 4 to 5, and order 5 is from 5 to 6, right? So this is how they will look like when we plot it on the timeline, right? So these are a kind of a segments, you can say, and segment has a left end and right end, right? So we have to find out maximum number of orders that can be accepted by the restaurant. So one thing it's already given in to us in the example is, for example, let's say, right? So if there is one segment of order, right, this starts at 1 and this ends at 2, and there is another segment which start at 2 and it ends at 3, right? So these are two orders. Let's say this is order 1 and this is order 2. Let's just assume that this is order 1 and this is order 2, right? So if we are taking order 1, we cannot take order 2, right? Because they have a intersection here, right? 2 comma 2 basically. So first order is ending at time 2 and second order is time starting at time 2. So that is not acceptable. So they have already mentioned in the uh, example here, they cannot share even a moment of time. So in one order ends in the moment other starts, they cannot be accepted both, right? So they have already given us in the example. So only one of these we can accept basically, right? Because they have one moment which is common at 2 basically, right? So this is very important point to note. Now what we how we are going to solve this problem is basically you can consider these orders as a segments, right? So we will create one class called a segment. The segment will have start time, right, s and end time, or we can say that left and right, right? So this is left and right, so one is left, right, and two is right. Here 2 is left and 3 is right. So we will create objects of segment class. It has two fields, left and right, and we will sort these segments based on the left, right, based on the left. So what it means is this is already sorted in this sense, right, because already you can see that 1, then this is 2, then this is 3, then this is 4, and this is 5. So these are the left of the segments, right, left points. So they are already sorted, but if they are not already sorted, we must sort them, right, for our solution to work. So we will create objects of segment types. Segment is a class that we created here. I'll show you quickly. So segment is a helper class. It's a Java bean. It has only two fields, left and right. And we will use a priority queue, right? So priority queue is a min max heap implementation in Java. So here we are going to put all these segments in priority queue, right? So for example, this is, let's say this is the segment S1, right? Let's just say S1. This one is S2. Let's say it is S2. Then this one is S3. And this one is S4, let's say S4, and this one is S5, right? So these are 5 segments we have. So we will put this in priority queue. So let's just assume that this is our priority queue, right? So priority queue, once we put these segments into the priority queue, how will they look like? So first segment which is in the front of the queue will be S1, right? After that S2, after that S3, uh, S4 and S5. So this is the order priority queue will maintain because we are sorting it based on the left values, right? So minimum left value is the top of the priority queue. Basically this is the front of the priority queue and this is the back of the priority queue, right? This is the PQ. So this is a priority queue. So we will create these objects, we will put it in priority queue, and one by one we will keep popping these objects, right? And what logic we are going to use to solve the problem is, uh, first let's say we will define our left side, right? Left side, let's say it is 0 in the beginning, right? So we will first pull this S1 from priority queue and we will check this left side of S1, so which is 1, right? So if this left side 1 is, if 0 is less than 1, right, then we will count it. Basically we will increment our count. So count is 0, we will increment it to 1, right? And we will update the left side to 1. 1 means the left side of this segment, basically, right? So once we take this segment, sorry, we will update the left side to 2, basically, which is the right side of this segment, right? So we will update this left side variable to 2, basically, right? Now when we are looking at the next, we will again pull next value from the priority queue. So S2 will come. S2 is this one, right? O2 means S2, basically. So in this case we will get we will again compare this left side. So 2, so 2 is not less than 2, basically, right? 2 is not less than 2, so we will not increment the count and we will discard this. So we cannot accept this, right? We accepted this order, we cannot accept it because there is a intersection here, right? So we will again update the left side now to the right side of this O2. Right side is 3, basically, right? So we will update the left side variable to 3. So now again we will pull the next value, which is S3, right? This is the S3 means O3 here. So again we will compare this left side. Left side is 3, right? So here we will not be updating the left side here, right? Because we have not taken this order, sorry. So our left side variable will be 2 only because we did not take this order, right? So left side variable is 2. Now when we are looking at this segment, the we will check its left side, which is 3. So 2 is less than 3. Yes, it is less than 3. So we will take this order. So we are taking this order and we will increment our count to 2, right? And at the same time we have to update our left side variable to the right side of this one, right? 4. Whenever we are taking it, we have to consider the means left, this right will become the left, right? So now left side will become 4. Now we are at the segment 4, right? We will pull this value from priority queue, we will get this segment 4. We will check its left side now. The left side is 4, so 4 is not less than 4, right? So 4 is not less than 4, so we will not count it, and we will go to the next segment, which is S5, right? Now here again we will take the left side of this S5 is 5, so 4 is less than 5, right? Which is true, so we will increment the count to by 1, so it becomes 3, right? So we exhausted all the segments, so we have taken this order also. So if you look at these segments, there is no intersection, right? We are taking this order 1, then order 3 and order 5, so there is no intersection of any moments here, and this is the maximum number of orders we can take basically. So 3 is the answer. So you can see, like, if you look at this example, 3 is the output that we have to output, right? So this is the logic to solve this problem. So uh, let's just go through the Java code for this solution. So I already showed you this segment class. It has left and right sides. This is the input that is given to us. N is equal to 5, so 5 orders are there, and these are the times, right? So left and right side basically of all the orders, right? Means starting and ending you can say, or left and right you can say. So first thing is we have implemented a comparator of for so that we can sort the segments, right? And comparator will compare the values on the right side. It will be comparing the right side values, right? So this is the comparator. So basically what I mean to say is, as you can see, this right side we will be using actually when we are comparing. So 2, then 3, then 4, then 5, and then 6, right? So this is as you can see, this is right side we are using descending order, right? So that's what the priority queue will use basically. The right side means ending of the segment basically, right? Ending of the segment. So after that we just defined a priority queue of segments, and we are using this comparator, right? This comparator that we have implemented here, we will just pass it in the constructor so that the priority queue will sort the segments based on this comparator, right? So how the it will sort it based on the right is like 2, then 3, then 4, then 5, and then 6, right? So that's what it will sort. So we will go through 0 to n, and we will create the segments from the given times, right? So for example, this is one segment, right? It has a left side, it has right side. This is another segment, like second segment, this is third segment, this is fourth segment, and this is fifth segment. So there are 5 segments. So we will add it into the priority queue, and we will define one variable called as left position, right? So as I said, this ls is basically what we were talking about, is the left position, right? So we will keep track of the left position of the segments, and acceptable orders is the number of acceptable orders that we want to count, right? So segment S we define here, and now we started polling or removing from the priority queue, right? So this one, right? So this S1 is first, then S2, then S3, then S4, then S5, right? And why it is like that? Because we defined a comparator like that, right? We are sorting based on this right side, right? So that's why it is like this in the sorted order in priority queue. So we will take it out one by one here from priority queue, and we will check if the current segment that we polled or we removed from the priority queue, if its left side is greater than our left position, right? It means that there is no intersection. If there is no intersection, we are going to accept that order, right? We will increment the acceptable orders plus plus, and we will update the left position by s dot right, right? We will update the left position by s dot right. So for example, if we take this 0 1, we once we are taking this order, we will update the left position by right, means 2, it will become 2 basically, right? 2 is the right side of this segment, so that's what we are doing. So we will go through all the segments. We will poll all the segment from priority queue. Polling means removing from priority queue, right? So it will remove from the front of the queue, and then we will keep checking if we are going to accept that order or not based on this logic, right? If the left side of the removed segment, if it is greater than the left position parameter, which means that they are not intersecting, in that case we are going to accept the order, right? At the end we are just going to output the acceptable orders from all these orders, right? So let's just go ahead and take execute this code. So 3 is the answer that we are getting, which is the correct answer, as you can see here. Let's take another big example. So let's take this example and make sure this also works. So 6, we have to update our input. So let's just quickly update our input. So 6, and these are the number of segments that are given to us, right? So 4, 8. So it's always a good idea to execute all of the test cases that they have given us, or at least as much as we can, so that we are confident about our solution. So let me just create this quickly. So this is the input now for the third example that they have. So let's make sure that this also gives us correct answer. So we are getting 2, and 2 is the correct answer for this example. So this is the way we can solve the restaurant problem. So how we solved it, let's just do a quick recap. So we used basically we created a segment class, right? So that we can encapsulate our information into this segment objects, and we used priority queue to create all the segments from this given information, right? This given information, and we defined a comparator, right, where the segments are sorted based on the right side, and we used a priority queue to sort those segments and process those segments, and we use this logic right here uh, to check whether we are going to accept that order or not. If it's not intersecting with the previous, like with the left position, then we are going to accept the order, right? So this is the way we can solve the Codeforces problem restaurant. If you are new to my channel, on my channel there is a dedicated Codeforces playlist that you can watch. It has over 80 different varieties of solved problems explained with whiteboarding sessions and examples and Java code. On my channel there is a big playlist called as lead code and lint code solutions, and there are over 200 solved different varieties of coding problems which are taken from previously asked in coding interview questions by Facebook, Google, Microsoft, Yahoo, Amazon, Apple, and many other big tech companies. Those are very important coding problems that constitute varieties such as BFS, DFS, matrix problems, graph problems, binary search tree problems, binary search related coding interview questions, dynamic programming problems, coding questions related to linked list, strings, optimization problems using priority queues, and many other logical questions. So if you go through those playlists, it can definitely help you in your coding interviews and Java interviews. If you like this video, if you find this video helpful, if you like the way it's been created by using whiteboarding session, examples and Java code, please give it a like. Also subscribe to the channel. Your subscription to the channel is really important for the channel, because that is the way the videos can reach to more people who need help in solving coding problems. Goal of the channel is to help as many people as possible who are preparing in their Java interviews as well as coding interviews. They can also watch these videos and understand how to approach different coding problems and what data structures, APIs and libraries of Java to be applied to solve different varieties of coding problems. If you like this video, please give it a like. If you have questions regarding this video, please put your questions below the description section. Also share this video with your friends and colleagues, and thanks for watching this video.